Okay, well, welcome back into the National Weather Service Columbia podcast with your co-host, Pierce Larkin.
And your co-host, Matt Gropp.
We are sitting here with you. We've got freshly brewed cups of tea in front of us, and we are ready to go talking about this forecast for tomorrow.
Overall, this is a tricky forecast.
Yeah.
The guidance has been pretty consistent, surprisingly, but it still remains fairly tricky in general. We'll get into that why. This is the SPC Severe Weather Outlook here. We have an enhanced risk up over kind of north central Tennessee. For most of central Kentucky. We have a slight risk that extends down from there and clips kind of our northwest corner of our forecast area. And then the rest of the forecast area is in a marginal risk. So this is for day 2, so starting tomorrow at 12Z.
The models over the past few days have slowed down quite a bit, gradually keeping that cold front to our west until the evening time. And that would explain why the slight risk has actually expanded from being over most of the Carolinas and parts of the mid-Atlantic to being over the Ohio and Tennessee river valleys and just merely clipping our forecast area.
Yeah, it's mainly because of the timing here late in the day with the storms expecting to come in after our peak heating at night. And we just are not expecting the instability in the Far East like we could see in the West. So let's take a look at the discussion a little bit. Let's go down to the southeast. So the main points here, the instability is going to be limited by warm temperatures aloft. We'll show kind of what they mean by that. The main forcing is going to be displaced northwest, basically where the enhanced risk was over Kentucky and stuff. Despite that, we've got strong wind fields, pretty good low-level moisture that will show, and we could have severe thunderstorms that develop along the cold front that move through.
It's possible, but looking somewhat less likely. Not somewhat, definitely less likely than it did a few days ago. So
yeah, I would say so. It was always an interesting event because the guidance was never showing a lot of deep convection, but they had really good environments for severe weather, and that's still what we're seeing now. The high-res HREF is now in range, which is the high-resolution ensemble forecast, and we'll take a look at what that's showing to show why we are a little bit more confident now in less severe weather.
So we'll get started here with the recent satellite image. I've got the RAPS 500 millibar heights and wind speed and vorticity overlaid over the air mass RGB, which is just a composite of several bands of satellite imagery. And what that's showing, you've got the cutoff low here over the desert southwest pushing. It's still digging a little bit as the jet streak rounds the base of that trough and ejects eastward. But we've got impressive cloud cover well out ahead of that. You can see that spreading over our forecast area.
You also see the primary source region down south of that low in Mexico is actually coming from the Pacific. And that will actually play a role in why we have some of that drier and warmer air aloft is from that source region being those high altitudes, drier air of Mexico.
And you can already see, if we could overlay, we'll go back here real quick and show you the day 1 outlook where they're expecting widespread severe thunderstorms across northern Texas, the Texarkana region, southern Oklahoma, the deep south.
The
Arklatex. Well, the Texarkana's in there too.
But I guess the
Arklatex, Texarkana region.
Yeah, there you go.
But you can see that widespread lift is increasing across western Texas already as that low starts to eject out. And we're expecting this to move eastward and then northeastward very quickly into the Ohio River Valley, forcing a very strong surface low-pressure system and dragging a cold front along with it. So let's get more into the forecast here, Matt. Why don't you start us off?
Sure. So you want to go to the 500 millibar chart. We'll take a look at kind of what's going on.
Back to the CONUS.
Okay. There we go. So that's currently. So we just saw that 500 millibar low sitting over kind of southern New Mexico, western Texas. Let's move that forward. You'll see that kind of transverse across Texas, then move into the Mississippi Valley, and then quickly cut up into the Ohio Valley and kind of Midwest area. And as that happens, that jet that is associated with the trough is going to lift generally to the north and west of our forecast area. And if you look at the ISO height that are on here, those black lines, you can see there's a general spreading out of them that occurs kind of over the Appalachians up into Kentucky and into the Midwest in general. And most of that spreading out or diffluence aloft is generally to our northwest. So that's one form of synoptic forcing that we talk about. And in this case, most of that's going to be lifting to our north, and that is going to play a role in why we're not totally confident on a big severe day.
So if we go down and look at the surface, let's look at
you can go to dew point.
Yeah, let's look at dew points.
That'll show the front really well.
Yep. So you can see that the surface low is going to be somewhere in this region of western Texas, moving quickly northeastward into Arkansas, dragging a warm front northward across our forecast area tonight, bringing in really, quite honestly, some deep moisture across the forecast area with dew points north of 60 degrees. You can see that cold front there marching across Alabama and then Georgia and then pushing into our forecast area by Friday evening. This is about, what would you say, 3 to 5 hours slower than it was on Monday?
Yeah, as opposed to coming through between like 2 and 4 p.m.
Yep.
Now it's a little bit more like
5 to 9.
Yeah,
something
5
like
to
that.
9
Yep.
After sunset for especially the eastern part of the area. So.
Yep. And then that cold front pushes through Friday night into Saturday morning with much drier air pushing in.
Yeah, dew point's nice to look at for fronts because temperature has the diurnal change.
Yep.
Where it warms up kind of universally during the during the day and then cools off at night.
Yeah.
Dew point kind of doesn't have that diurnal trend to it, and you can kind of see the moisture gradients a lot easier that are associated with those fronts.
Yeah, you don't always get a quick temperature drop after a cold front pushes through.
Especially if there's clouds ahead of it and it's sunny behind, it can actually not
warm
change
up.
much. Yeah. So.
And here where we get some northwesterly winds off the Appalachians quite often, we could get some warming from that. So let's take a look at some of the more convective parameters. Yeah. Well, actually, I want to show that surface low real quick. Let's see. Have a what they say, a bombogenesis event here.
Don't think is it going to be technically a bombogenesis event?
I think it falls from it's going to be close. It's around 1,000 there. It's going to be sub 980, I think, of the Ohio Valley.
So it'll be close. Yeah, bombogenesis is what, 24 millibars?
24 in 24 hours.
In 24 hours, so it'll be close.
Yeah, it'll be fairly close. Either way, this surface low undergoes rapid intensification as it moves through the Arklatex region up into the Ohio Valley and starts dragging this cold front towards us. You can see we actually warm up quite a bit tomorrow ahead of the front, and with that plus the deeper moisture and a front pushing through, you would kind of expect this to be a more significant event than the models are showing.
Sure.
Let's show some of those convective parameters
go
here.
To the let's show precip first.
Okay.
Show
yeah, that's a good idea.
Yeah, convective precip. So this is the deeper moisture that the model is parameterizing and showing, and this is from the GFS here. And you can see it kind of has a little band of deeper moisture and convection that occurs as that front comes through late tomorrow evening, mainly focused in the upstate back across Georgia. So
that's actually been consistent across the cams as well.
Yeah, that's been consistent. We'll show some of the higher res guidance that will give us a little bit more confidence in what's showing here. But yeah, if you want to look at some of the convective parameters, this is where this event is a bit confusing from a
extremely bizarre. So looking at the way that mixed layer CAPE, we talked about that in a previous episode, how CAPE is just kind of it's a catch-all for instability. It's one of those things that we use as an initial look at how unstable the atmosphere is going to be. And typically around here, we're looking for values between 500 and 1,000. That's usually our 50th to 75th percentile of CAPE for all severe weather events for us typically, especially in the cool and spring season. Summertime, it gets a little higher. But like I talked about before, having those warm surface temperatures and the deep layer moisture, we actually do get mixed layer CAPE values up close to 1,000 across the forecast area with strong deep layer shear present across the area. And that actually yields, what do you want to look at next? Let's look at supercell composite, or we want to look at mid-level lapse rates and talk about
that? Sure.
Some of the source region stuff.
The mid-level lapse rates will show kind of the reason we're not expecting a widespread severe outbreak.
Actually, let's just go straight up to the soundings here.
Okay,
we can kind of explain that. This is supercell composite.
Yeah, so just pull one from like Augusta there.
Yep. So supercell composite is 7. This will kind of explain why this is such a bizarre, why the models really aren't. It's really confusing why the models aren't resolving stuff.
Right, so we look purely based on parameters here. We showed this in one of our last forecast discussion videos. Pierce is doing something.
I'm gonna draw.
Oh, we got the drawing out. Here we go. All right, so we see on the thermodynamic diagram, we see over 1,100 mixed layer CAPE, and then looking across to the shear parameters, we see over 300 surface to 1 kilometer SRH, strong deep layer and low level shear, with nearly 70 knots of 0 to 6 kilometer.
Yep.
And then if we look at the actual SQT log P diagram, we see this area of very dry air and subsidence aloft. And this is the main reason guidance in general is suppressing a lot of that deep convection tomorrow, and why we're not expecting a large severe outbreak.
You can see the dry air there by the temperature which is this red line right here, and the green line, the dew point, there's a large gap between the two. That just indicates a big area of dry air aloft.
Yeah, that's indicative of sinking motion, where you get that rapid increase in dew point temperature at the bottom of that sinking layer and a general warming through that column. And that's what SPC was talking about with those warm mid-level lapse rates. Guidance is a little bit all over the place on exactly how strong it is. Some have that red line further to the right, so a bit warmer.
I think we still had that wrap sounding pulled up here. Let me see. I think we got it right there.
Yeah, so you can see the wrap has the same idea here, but it's a little bit moister in the mid-levels, and it's a little bit stronger with that initial inversion that occurs, that warm nose that occurs at the bottom of that layer of subsidence.
So we talked about on the last forecast discussion, this blue line is the parcel path that the rising air would take as it's lifted. And this little warm nose right here would be a real challenge for that to actually pass through unless we had strong forcing.
Right. So since we don't have that forcing, we were talking about the diffluence from that trough and the jet associated with it going to our north. We basically don't have any support broadly in the atmosphere to help lift air that makes it up convectively to the bottom of that layer.
And normally if you had the level of synoptic lift you'd have, this cap right here, that's what we call it, would lift and cool slowly, slower than it would on the small scale. But the large scale circulations in the atmosphere, that large scale lift would lift this warm nose and cool it so that this parcel has an easier path, so that when the cold front, which acts on the lower portion of the atmosphere, so the cold front's not super deep, but when the cold front actually acts on that parcel of air, it can get into the synoptic scale and continue to rise higher. So
overall, you can kind of see below, I guess, Pierce, if you want to try
I'll draw it.
Yeah, try to circle the lowest level, like up to 700 millibars, kind of that saturated layer that's there. So basically what the model is showing here is that lowest, about 3 kilometers or so, 2.5 kilometers, is going to be saturated, so a cloud layer there. And it's rising and then hitting that drier, warmer air and basically getting entrained out. So you have drier air mixing in with that moist convective column that's coming up. And when that happens, basically the thunderstorm dies. And in this case, we have a lot of shear aloft. So essentially you have too much dry air entraining and too much shear for this amount of instability. And you don't see a large amount of convective columns that can develop, despite a really impressive shear profile that would be capable of strong tornadoes.
This is a really, really impressive sounding just in general outside of the swarm nose here. I mean, if you were able to actually get a thunderstorm in this environment, that's why there's still a slight risk maintained across the southeast, because this is a big parameter space between Georgia and South Carolina. And if you did get a thunderstorm to go up in this, it would produce severe thunderstorms or severe weather, no doubt.
Yeah, we said it from the beginning on this event. It was a high ceiling, low floor kind of event where really nothing could happen. It could just be a couple showers, or we could have some pretty strong severe weather. We're much more confident in a lower impact event at this point, but it's still possible, and that's why the slight risk is still out. We take a look at the HREF here. This is the high resolution ensemble forecast, so it's a mix of 4 models and then their previous run, so it's a total of, about 12 model runs or so. Or 8, whatever
Whatever it is.
And this is showing the paintballs, as they're called, which is areas of composite reflectivity greater than 40 dBz. And it's overlaying all those different models on top of each other.
So you can see as the low would be about here tomorrow morning.
It is
moving.
Yeah, it's 10 models. It's the last. You can see them there on the right. It's got the HER, the HRNSSL, the ARW, the FV3, the NAM Nest, and then the previous run of those.
So this one up here in this bracket, these are the most recent model runs at 12Z today, and these are the 0Z runs from last night. So it's a good way of trending towards things without discounting previous forecasts. That's what this ensemble does really well. So if I gotta go back to
there we go.
Get out of the drawing board there. But the low pressure system is up here in Arkansas, moving quickly. The strongest forcing for ascent is going to be up in western Tennessee, moving into central Kentucky, where they outline that enhanced risk. They're actually expecting a very strong line of thunderstorms to push up through that region. Tomorrow, I actually have a personal connection being from Kentucky, so I'm always thinking about Kentucky weather too. But the cold front, you can kind of see that cold front feature as it pushes up into the southeastern U.S., Georgia, South Carolina, North Carolina, but it really starts to die out owing to that subsidence aloft. And what you'll notice here is just similar to the GFS, the cams are starting to pick up on more organized, possibly some more organized convection, more widespread convection up in the upstate in western North Carolina, a little bit closer to the synoptic scale lift, where there may not be as intense of a cap in the mid-levels of the atmosphere.
Right, so this kind of lines up with what we were seeing in those soundings. It's a little tricky because if you look directly at the soundings, you'd think, oh, wow, this is a pretty good cape for the southeast, great shear. This could be a pretty widespread event. We have a front associated, but there is other factors that can impact that.
A strong front, too. So it really does kind of tie together the mesoscale and the synoptic scale of the atmosphere, the different motions that tie into one another. While synoptic scale lift is never strong enough to initiate a thunderstorm by itself. Even if you have strong mesoscale lift, in this case, that cold front would be a mesoscale lifter.
Yep.
Even if you have a strong lift in the low levels, you still need synoptic scale lift to erode potential warm layers in the atmosphere so that you can actually get that lift freely into the atmosphere and it can become a thunderstorm.
Yeah, it's definitely kind of a strange event where
it is.
Usually when you get this much cape and this much shear associated with a mesoscale forcing like that front, you would expect a pretty big severe weather event here, but not everything's lining up.
Yeah, you can even see in the href, which tends to over smooth things. You can see how strong that cold front is as it approaches tomorrow.
Again, this is dew point here, but it gives you a sense.
Sorry. Yeah.
The temperature gradient's gonna be a little different, but your dew point temperature is gonna drop a good. Let's see, what do we got there? That's like 30 degrees or so.
Yep.
In a 25-mile range. So Pierce got the cold front there.
Oh yeah, got to draw the cold front and the warm front. I mean, it helps people visualize this.
Yeah, for sure.
The key takeaways from this, there's still a bit of uncertainty. If we were to get a thunderstorm in an environment like this or an environment like this, it would pose a risk for all severe hazards, hail, wind, tornadoes.
Right.
However, confidence is increasing that we won't have any significant convection that will be able to actually tap into this environment.
Yeah, anything we're expecting at this point will be much lower topped.
Yes.
With a lower end severe potential because of that.
Yes. So do you want to go through a little bit of the rest of the forecast going into early next week real quick? I don't think there's a lot going on, but
it's just
generally expecting temperatures to...
We'll be below average for the first time in a while.
Yeah, temperatures behind that front are going to cool down, and we're only going to get into the low and mid-60s on Saturday, and then that'll continue into the day on Sunday as a high-pressure system pushes. I'll show that real quick. As a high-pressure system pushes into the mid-Atlantic, and we get north and easterly flow. And then we start the cycle right back over again next week, getting springtime temperatures and possibly another front moving through by middle of next week. So I think that's a good summary of the weather.
Yep, sounds good. Again, stay weather aware tomorrow. It's a still somewhat unconfident event in some regards, and we'll keep you updated, and we'll have more updates out in the morning. So
be sure to follow us on Facebook and Twitter for the latest updates, and give us a like and subscribe on our YouTube channel.
All right, have a good one.
Thank you all.